Hello, this is Shishir Khadka, and this is my Triple E 120 Lab 1 video. So I'm in Triple E 120 with Professor Steve Millman on Tuesdays and Thursdays from 1:30 to 2:45. So let's get started. So right here is the design of the half adder, and if we run a simulation here, if A is on, we can see that A goes through the XOR gate, and since this is on, this is off, the sum is bright green. And if we vice versa this, the sum is also green. And and as we can see here, it does not go through the AND gate because it needs both of them on to go light up cry. However, if we do light both of these up, two ons in the XOR gate will means that this output will be off. But since there are two ons here, the AND gate will light up the cry output. And if we can see here, uh, we're a bit at it right here. This is the GTKWave for my has adder waves. And as you can see here, a this pretty much runs the same thing as in the design. A0 B1 equals sum one, A1 B0 equals sum one, A1 and B1 equals cry one, but sum is zero. And as we move back here, if we were to open the full adder, now this one is a bit more complicated, but this is my design for the full adder. So if we run a simulation here, the A input, if it's only on, since one of them is on and one of them is off, the sum has been outputted, and you can see it branch out. But since it doesn't pass through any of these AND gates, the C out one doesn't work. Same thing with B. So pretty much if it's individual inputs, if only one of the three has been on, the sum output would be light up. But if we have at least two, the C out output would be light up. And we could see the same thing for here. But if we have all of them on, that means that both the sum and the C out has been outputted. And if we go back here to the incrementer, yeah, so pretty much this is the simulation for the incrementer on GTKWave. And yeah, so if we were to go to open to 4-bit adder. So as we can see here, this is the 4-bit adder, and pretty much, oopsies. All right, so if we start the simulation, we put one right here, and then let's say we put two. So Y output would be three. So if we do something like that, yeah, the Y output would be five. For if we turn this on, and let's say the B output would be three, this would happen. And if we put one more, that means that the overflow would occur. So this kind of, yeah, so it's like a 4-bit addition. And if we did play around with it, say add one more, the Y output would be A. So it's pretty much just a full, like a 4-bit addition with 4 or 5 bits. Um, so for the test cases, this is my test case right here. As you can see, I made them customized. And on my documents right here, so yeah, so that my test motivation is just basically why I did that, why I use those test cases, and a lot of them passed. And as you can see here, 3 plus 2 with an unsigned to 0 is equal to 5, or Cn pretty much. And yeah, and if we were to go on GTK Wave, full adder, 4-bit adder, there you go. So if we went like this, 2, 3, Cn is 0, the Y output is 5, with the no C out with no overflow. If we went to something like this, A is 0, 2, Cn is 0, the output is 2. If we did something like this, where input is 5, output or another input is 4, the Cn is 1, and therefore the Y output is A, or 10, which results in a C out of 0 and an overflow of 1. So pretty much this confirms that the design that I made is um, accurate, like it's supposed to be. And yeah, just playing around with and when I played around with each test case for on the GTKWave, it confirms that the test cases and the answers for that table right here, where is it? Right here, is 100% accurate. So yeah, that is my lab, and thank you for watching.